Okay. In this video, I will take a general overview of the Google search engine before I focus on how the system is distributed, and ultimately I'll take a deep dive into the architecture of a Google computer cluster from 2003 and how a query was handled by Google Web Server. I'll finish with an overview of the network protocols utilized by Google and how they assure secure communication over their network. The Google search engine was released on the 4th of September of 1998. It started in the dorm rooms of its creators, Larry Page and Sergey Brin. Over 26 years, Google search engine has moved worldwide with over 100 data centers and over 900,000 servers, supporting over 3.5 billion daily searches worldwide. This enormous amount of data is processed as Google utilize cluster computing. All of the information on the Google computer clusters is based on the 2003 research paper, Web Search for a Planet, the Google Cluster Architecture. The Google search engine utilizes cluster computing, with each cluster containing over 15,000 off-the-shelf computers running Linux. They were able to use off-the-shelf computers as they favored reliability in software over hardware, cutting costs in the computers as specialized hardware was unnecessary. They also opted for open source operating system as it is much cheaper and provides more freedom than getting hundreds of thousands of Microsoft Windows licenses. Furthermore, they significantly increased throughput as they realized they could utilize parallel computing to greatly increase speeds, as they could use multiple computers to complete a single task. Due to this development, price to performance ratio is now more important than peak processor speeds. The Google search engine is a distributed system that utilizes cluster computing with many clusters worldwide. This provides a better user experience as the traffic is distributed by geographical location, significantly reducing network latency. Furthermore, by breaking up the processing to many separate clusters containing thousands of machines, they greatly increase the redundancy of the search engine, as it is highly unlikely that all clusters would go down at once. Processing takes place in each of the Google computer clusters. The computer cluster that is used for a search from a user is determined by the DNS-based load balancing system, which selects the cluster based upon the geographic proximity of the user to a physical cluster. It will also consider the available capacity at various nearby clusters. This system is highly decentralized, as due to the worldwide nature of the Google search engine, there are many data centers spread across the world. This led Google to utilize cluster computing as a form of fault computing, while also using replicated data centers to ensure reliability and fault tolerance. Here we have a general architecture of a search engine. Here, a query starts at the user, then goes through the search engine where the query is passed, and is then moved on to the index files. The index files receives its information from web crawlers, which crawl over the web, finding information on every web page and indexing it to the index files. From the query, the index files gives relevant documents to the ranking algorithm, where those files are then ranked by how relevant they are to the search, and then returned to the search engine, which returns them to the user. This is the prototype architecture for the Google search engine from 1998. I, however, will be focusing on the architecture of a cluster from 2003, as it, while still outdated, is more relevant than the prototype architecture. Here we get a closer look at the general architecture of the cluster, or a section of the cluster. We can see on the left the user computer. Once it sends a search, hardware load balancer will pass the query on to a Google Web Server, which is connected to a spell checker and an ad server. The Google Web Server then passes the information onto the index servers, which return that information to the Google Web Server, where it is then passed on to the doc server. From there, Google Web Server returns it back to the user. A closer look at the Google Web Server side of the architecture, we can see that there is a hardware load balancer that passes the request on to whatever server Google Web Server is free. Google Web Server then handles the query coordination between the index and doc servers. This is a closer look at the index servers. We can see that Google utilizes sharding and replication of shards to return extremely fast searches. Each shard is responsible for the ID lookup, or the document ID lookup of one word of the search. That shard is then replicated across multiple computers for high response times. There can be as many shards utilized as necessary, replicated as many times as they are needed, as there is no communication between shards, only between the web server and the shards. Here we have a closer look at the doc server. While the figure does not show a load balancer, there is one still present similar to the index servers, as this provides more consistent usage of the computers. Similar to the index server, each shard is responsible for providing the document information relevant to the doc ID provided by the index server. Each shard is then replicated similar to the index servers as many times as necessary, as there is no communication between shards. Furthermore, these load balancers are all software based, as it provides a high level of reliability to the system. In addition, as Google favored reliability in software, it allows the easy monitoring of the hardware, resulting in easy management of that hardware, where if a device is found to be incorrectly operating, it is taken out of the load balancing pool until it is fixed. There are many protocols utilized by Google. Some of these include TCP, which is the primary protocol used by Google, as it establishes reliable and ordered communications and is the backbone for most internet traffic. They also use UDP combined with their self-developed QUIC protocol, or Quick UDP internet connections. They self-developed this as an alternative to TCP, while developing it with HTTP 3 in mind, as it provides in order to provide faster connection and improve data transmission. It also reduces latency in web browsing making it very beneficial to the Google. Furthermore, they also use transport layer security and HTTPS. Security of communication is assured by Google through the use of HTTPS and TLS. Now, security of communication has a high priority due to the sheer amount of data, sensitive, personal, and just general data that goes through the engine every day. To put this priority into context, it's only just below that of an online banking service, as that sort of service has very sensitive data in the form of banking information, which has the highest priority for communication security.